21D is all about quantiles. So the quantiles are the values at the bottom of your normal curve. So think about, we always have our mean here. The numbers you write here, these are your quantile numbers. Okay, so we're going to be looking, we are going to know a specific area, so then we can use the area under the curve. Because remember, the area here tells us the probability of whatever we're looking at. So if we know the area, we want to find the quantile, we're going backwards with our normal distribution. So if you go to your distribution button on your calculator, going backwards in math is just your inverse normal. All right, so your inverse normal finds your k value. I think it's always helpful to sketch a normal distribution because it helps you visualize what's going on. It can also help you verify if you are in the right ballpark. Because let's think about this. There's mean 70. So if 70 is our mean, our standard deviation is 10. We don't need to go through all of that. But where would the k value lie if I'm talking about x being 95% of my probability? So think about this. I'm going to kind of try and make it like, if I want to have 95% of a 95% probability, it's got to be way over here. So it's going to have to be more than 70 in order for my k value to be correct. So go ahead and do your inverse normal, which once you get into the distribution button, it's the third one down. We just enter our area. So in this case, it's 95%. Our mean is 70. Standard deviation of 10. Paste. And our probability that x is less than or equal to k equals our 95% happens when k is 86.4. So that makes sense when I look at this because 86 is to the right of 70. All right, we could also use inverse normal. They're going to give you so many different types of information. And I think the hardest part of the normal curve is trying to understand which way to go. So if you don't know a mean or you don't know a standard deviation, we're going to convert into z-scores to figure out what's missing. So think about it. For a z-score, we always know the mean is 0. We always know the standard deviation is 1. So we can use that to cheat. All right, so if we look at example 8, the weights of an adult scallop population are known to be normally distributed with a standard deviation of 5.9. If 15% of the scallops weigh less than 58.2 grams, find the mean weight. All right, so we don't know the mean weight, but we do know our area is 15% or 0.15, and we know x, a specific scallop we're looking for at 58.2. All right, so let's first convert to our z-score. So what we want to know is, thinking of our mean, we're going to look for our z-score value. All right, so let's go to finding the z-score. Go to the distribution. We're looking for the z value, so that's the inverse normal. Now our area is 0.15. we're going to use the z-score values, so that means our mu is 0 and our standard deviation is 1. So go ahead and paste. So we find our z-score to be negative 1.0, and I'm going to write a few of these values down. 0, 3, 6, 4, 3, 3, so forth. So this should make sense. My z-score is negative, which means it's to the left of 0. Negative 1.03 is somewhere over here because that corresponds to 15% of the data. That is 15%. So that makes sense to me. All right, so now we're going to go back to the z formula. The z-score equals x minus the actual mean and actual standard deviation. Well, this is our z-score. So we can replace our z-score with negative 1.0. Just keep this number in your calculator because we're just going to use it. We know the x value is 58.2 minus mu. We don't know mu. That's our question mark. And the standard deviation is 5.9. Now we just solve this equation for mu. So since this is already in your calculator, to get mu by itself, we just need to multiply both sides by the 5.9. So take your answer times 5.9, which is negative 6.114, and I just kind of write a few of those numbers down, equals 58.2 minus mu. Now we're going to subtract the 58.2 from the answer. You get negative 64.3 equals negative mu. But our mean is never negative. So you notice this negative here changes both our signs. So my final answer, mu, is 64.3. All right, last problem. And this one's kind of a doozy. I used every single space available. So the first thing I did is I drew a little picture just kind of up here. I did my normal distribution. It says find both the mean and standard deviation. That's what makes this one tricky. It tells me that for my x value, this is going to be for x, not z, that if I go less than 20, this little area here is 0.1. It also tells me greater than 29, somewhere over here, this is 0.15. So this just, the little sketch gives me kind of an idea of what it is we're doing. All right. So let's get our corresponding z-scores for each of these. So let's do our inverse normal, where our area is 0.1, and the corresponding z-score for this one, let me go ahead and plug it all in. I get z equals negative 1.281, oops, if I write the right numbers down, 28155. All right, this makes sense to me. See how this is negative? That corresponds to the 20. These are your x values. The z values, this is negative 1.28155. Okay. Now we're also going to convert this one to a z-score. When you plug your 0.15 in for your area, and your we're going to just kind of ignore the 29 right now. We're just using the area, and for the z-score, remember your mu is 0, standard deviation 1. That corresponding z-score is 1.0364. See, that corresponds to this number. This is on the right side of the mean, So that makes sense. It's a positive 1. Okay, so far this is all fitting together. All right, so then what we're going to do is write 2 equations with each of these. So I'm going to make one equation with this one where x is 20. So that means 20 minus mu over the standard deviation equals this corresponding z-score. Now I'm going to write another equation using this one. So this is 29 minus mu divided by standard deviation equals positive 1.0364. So we now have 2 equations with 2 unknowns. This is a system of equations that we've got to solve for both. So the first thing I'm going to do is multiply both equations by my standard deviation. So I get 20 minus mu equals negative 1.28155 standard deviation sigma. Same thing over here. 29 minus mu equals positive 1.0364 sigma. Okay. Now, this is what we're going to do. I'm going to take this equation and subtract it from this one. So first of all, I'm just going to write this down. And then we're going to subtract it. Because watch what happens. If I subtract this whole equation, it means I got to distribute the negative. So this 29 becomes negative, mu becomes positive, this becomes negative. And when I combine my mu's together, they cancel out. Then I get 20 minus 29 is negative 9. When I combine my 2 negative values here, I get negative 2.31798 sigma. I might have a few more decimals in there than you, but that's okay. Now to solve for sigma, we just divide both sides by that, yada yada. But this tells me my sigma value is 3.88. Then once I know sigma, I can just plug my sigma value in for sigma here and solve for mu, and I get 25.0. So these are the 2 solutions. Make sure both are 3 sig figs. That's why I needed the 0.0 here, because it doesn't specify our decimal point. But the tricky part of this, if you have 2 unknowns, notice both the mean and the standard deviation are unknown. So we had to write 2 different equations. And then we can combine 2 equations either by linear combination, where we kind of subtract them to make the mu's cancel out like this. Then we're down to just 1 variable to solve. Once you know that variable, you just plug it back in to find your other variable.